Hello, students. Welcome to this episode of Mathmeatics. We are going to be talking about in this episode compound inequalities. All right, and compound inequalities, you can find solutions of compound inequalities either by identifying whether the solution set of distinct inequalities overlap. So, keyword here is overlap, or by combining the solution sets to form a larger set. Okay, well, first off, before we even start talking about this, I want to talk about what we mean by a solution set. So let's say, all right, I'm going to talk about our, I'm going to have this box here, all right? And I'm going to put a little person, draw a little person in this box. And I'm going to draw another person outside the box. Okay. Now, this is the person that's outside this box, all right? This person with the skirt, all right? That person is not, this person here is not in our solution set. Anything that's inside our box that I've drawn is inside the solution set. All right, hopefully that kind of explains that a little bit better. All right, so let me erase my little figures here real quick. All right, now graphing compound inequalities. We have two types of situations that will happen with compound inequalities. To graph the compound inequalities, we're going to have the word, it contains the word and when we have the word containing and, there's an overlap, okay? And the overlap of the two graphs cause it to where there's a true solution for both of those inequalities. We can also have, and it also expands the set that we have, okay? Now, the other possible compound inequality that we can have is compound inequalities that contain the word or and each graph. All right, now let's look at this. I'm going to look at this first graph right here. So we're not even going to look at, we're not even looking at these two, okay? We're just going to talk about x is greater than or equal to 3, okay? When x is greater than or equal to 3, all right, we're just talking about all the set of values, all the set of numbers from 3, including 3, all the way to positive infinity. Anything below 3 won't be true for that inequality. Okay, well, so now we know that solution set. Well, now let's talk about this solution set, because we're talking about it completely separate. We're going to talk about x is less than 7, okay? Now, if I look at that, I'm talking starting at 7, and then it's all the values below 7, including 7. So any value greater than 7 is going to not be true. Now, we're going to talk about this next situation. Okay, so those are two separate graphs. We're now going to be talking about this graph here, where we have x is greater than or equal to 3, and so x is less than or equal to 7. So here we had them separated in these two situations, but now we're going to combine those two. So by combining those two, I'm going to only look at where the solutions of those match, which is all of those values from 3 to 7. Okay, now anything below 3 will only be true for x is less than or equal to 7, and it'll only be true, and for any value that's greater than 7 will only be true for x is greater than or equal to 3. So we only want to look at the values that are going to be true for both. So that's why we're only looking at from the values here from 3 to 7. Okay? Now let's talk about inequalities containing the word or. All right, if I look at this first one, the x values are less than -2. And here the x values are greater than or equal to 1. Now I'm only talking about or. Since I'm not combining them, there's going to be no overlap. There will never be any overlap when we have the word or there shouldn't be if it's a correct or statement. All right. And so x is less than -2 or x is greater than 1. Okay? Now let's actually talk about some actual real-world problem, or some practice problems. In the first one here, problem number 1, we're talking about compound inequalities and being represented by a phrase. We also want to make sure that we graph our solutions. So the first one says all real numbers greater than -2 and less than positive 6. So if I'm going to write n, that's going to be my variable. So n has to be greater than -2, and n is less than 6. Okay, Now let's talk about graphing this. I'm going to graph this. I'm on a different color. Okay. Oh, wait, let me do purple for the numbers. So all I have to do, I know negative 2 is there. I have 0 here, and I have 6 to the right of my 0 value. And it says that n cannot equal negative 2, so that's going to be open. And n can't equal 6, so that's also going to be open. Looking at this inequality, it says n is greater than 2, so that means I'm going to graph my graph that way. And n is less than 6, so I'm going to graph my line that way. So now I know it's all the values that are included from negative 6 to positive 6. Now, we're not done. I want to talk about combining this into one inequality. I'm going to combine my negative 2, or n is greater than negative 2, and n is less than 6 as a inequality. The first step I want to do is I want to take my n greater than negative 2. I want to switch. So I want my negative 2 to be on the left side and my n to be on the right side. All right, and then we have n is less than 6. All right. Now, when I switch this, I need to switch my sign. So now this becomes less than, okay, symbol. So it's saying the same thing. Originally, I'm saying n is greater than negative 2. Now I'm saying negative 2 is less than n. It's still saying the same thing. N is greater than our value of negative 2. But now, if I were to write this, I'm going to put n in the middle, less than 6, less than negative 2. And I'm going to write my compound inequality just like that into a single inequality. And it makes sense. Negative 2 is less than our value of n, is less than the value of 6. Okay? Now let's talk about b. It says b, all real numbers are less than 0 or greater than or equal to 5. So that means I'm going to use n again. N is less than 0. Or n is greater than or equal to 5. Okay. So let's graph this on a number line. So I have 0 here. I'm going to go ahead and put negative 1. And then I have 5 over here. Okay. And it can't equal 0. Alright. It's going to be open there. But it can equal 5. So that's going to be closed. Alright. Now the values of n are greater than 5, so that means I'm talking about going that way on the number line. And the values of n are less than 0, so I'm talking from 0 to that way. So look here, all of this value here, none of that gets shaded, okay? Now, I can combine these two into a single inequality just like we did over here, but it's going to be kind of confusing. When we talk about n negative 2 less than 6, negative 2 less than n less than 6. That makes sense. But let's look at this. So I'm going to come down here, and I just switch. So that's going to be 0. Go away. 0 less than, hold on. I need to change that to greater than n. Or n greater than or equal to 5. See how my n's are in the inside? I want to, before I can combine those, the n's need to be on the inside. So then I'm going to rewrite this as 0 greater than n greater than or equal to 5. This is why it's confusing, because if I notice, n0 is not greater than or equal to 5. It's less than. So that's why it gets confusing with an or statement, okay? Just know that you can combine them as an inequality, and when you graph it and you talk about the solutions of it, break it apart, and that's going to be easier in terms of discussing it. All right, I will see you in the next video where I will talk about problem number 2.